So we're going to be hearing from Alice Brooks, Khosla Ventures, Rohan Ganesh of Obvious Ventures, Galim Emanbayev, Lightspeed Venture Partners, Corinne Riley from Greylock, and wrangling these judges will be my good friend and colleague from TechCrunch, Anthony Ha. Round of applause, everybody.
Thanks, Mike. Hello, hello. It is very exciting for me to be here. This is my first time on the Disrupt stage since 2019. But of course, you're not here to see me. You're here to see the startups. So let's talk about the startup battlefield. The first thing I should mention is that the startup battlefield isn't just here. There are actually going to be 180 startups presenting at the Pitch Showcase stage. But here, we're going to be seeing the top 20. That represents less than 1% of the total applicants. In this block, we're going to be seeing the first 5 of those companies. They're going to present for 6 minutes, and those presentations will include live demos, which is always a little hair-raising. Then we're going to have 6 minutes of Q&A with the judges behind me. The judges will be helping us choose the finalists who present on Wednesday. They're going to be focusing on the viability of the companies and on the potential impact that can either be social impact or financial impact. Again, on Wednesday, come back. You'll see the final presentations. They're going to be competing for the Disrupt Cup. That includes $100,000. And I should mention that TechCrunch does not charge any fees at any point in this process, and we don't take any equity in the companies. We're just, nice. So those are the rules. Let me introduce our awesome judges. First up, we have, just the first I'll mention, let's say. First up is Alice Brooks, partner at Khosla Ventures, where she's interested in sustainability, food, agriculture, manufacturing supply chain. She's previously founder and CEO at Ruminate, a STEM education company. Next up, we have Rohan Ganesh, partner at Obvious Ventures, where he invests in companies at the intersection of science, technology, and healthcare. Previous to Obvious, he led venture investments in healthcare, biotech, and diagnostics at the Google spin-out Verily Life Sciences and at North Pond Ventures. Next, we have Galim Emanbayev, partner at Lightspeed Venture Partners, where he focuses on health tech and services investments. His interest in health is rooted in his childhood experiences growing up in Kazakhstan and following his father on rural medical trips. Last, but definitely not least, we have Corinne Riley, a partner at Greylock, where she partners with early-stage founders who are creating data and AI products at the infrastructure and application layers. She built Greylock's Edge program and launched Greylock's Scout program. So give it up for all of our awesome judges. All right, I'm going to bring out the first startup. Before I do that, I do have one request for you. Please keep in mind, these startups have been preparing for months for this presentation. They've been working so hard. They've been working hard for even longer than that, building, their own startups. And so I just ask that you show them your support, show them how excited you are to be here, watching them demonstrate on this stage. And so let's put that to the test. Let's bring out NitroFix. Presenting for NitroFix is co-founder and CEO of Ofira Malamed.
Hello, I'm Dr. Ofira Malamed, co-founder and CEO of NitroFix. At NitroFix, we have developed a groundbreaking method for producing decentralized, emission-free ammonia from just water, air, and renewable energy.
Okay. Sorry, where do I see my slide?
Oh, there you go.
Okay. 1 minute, technical. The other side. Okay, hi everyone. I'm very excited being here, so I'll start. So I'm Ofira Melamed. I'm NitroFix co-founder and CEO. At NitroFix, we are changing the ammonia world. We have a decentralized, affordable production of green ammonia. So you probably ask yourself, why ammonia? Ammonia is the world's second most produced industrial chemical. mainly being used as a fertilizers. Around 200 million tons of ammonia are being produced every year. Its production method was invented 100 years ago by Professor Haber and Professor Bosch. Both of them got a Nobel Prize for their invention because it enables a mass production of ammonia, which enables the growth of the population all around the world. This process includes two steps. The first step is production of hydrogen, which is made out of fossil gas and emits huge quantities of CO2. The second step is reaction of hydrogen with nitrogen at elevated temperatures and pressure. This process emits huge quantities of CO2. For any tons of ammonia that is being produced via the Haber-Bosch method, around 2.5 tons of carbon are being emitted. This is a staggering number. It's around 450 million tons of carbon emissions every year, roughly as Great Britain emits a year. So if we look at it, we have the global emission. Usually those are huge facilities located in remote places, and they are using fossil gas, which adds supply chain risk and price fluctuation. And this is where we come, Nitrofix. Based on technology developed by Professor Ronnie Newman from the Weizmann Institute, Nitrofix was established. The technology uses only water, air, and renewable energy that goes into our electrochemical cell, and we are producing ammonia with zero carbon emission. This electrochemical cell is known as electrolyzer. We have our proprietary catalyst to do this reaction from just water and air, and this proprietary catalyst enables us to do the reaction at low voltage. And the meaning of low voltage is low power consumption, and therefore low price of production. It is a simple and safe operation, and it's a one-step process, which means low capex. For our customers, it is constant and low production cost of ammonia. It's eliminate the supply chain hurdles and the transportation cost that is associated with the ammonia. And of course, it is a green solution. Now we will move to the demo, live demo at my colleagues from Israel. So Dr. Meital Alon, so let's move to the demo. Thank you. Go ahead, Meital.
Thank you, Fira, for the introduction. I'm thrilled to demonstrate our state-of-the-art ammonia-producing electrolyzer system featuring a 250 centimeter square active area incorporated with our breakthrough catalyst. This system is fed with air, water, and renewable electricity to produce ammonia locally with zero carbon emission and with the lowest production cost. Back to you, Phil.
Thank you. Let's move back to the slide. So what we are going to sell, so we are planning to sell the decentralized green ammonia generator. We are going to do a strategic partnership with electrolyzer manufacturer that we would bring our core knowledge of production of ammonia, and he would bring his core knowledge of electrolyzer manufacturing, and we would sell the generator, the consumables, the maintenance service, and of course licensing is an option. So if we look at the market, it's, as we said, it's a huge market. Nowadays, mainly fertilizer, refrigerant, and raw material. But as regulations are changing, a new green energy market is evolving. Ammonia can be used as a nitrogen carrier. It is already being used as a fuel for maritime. There's one vessel that is going out around the world with ammonia engine and ammonia, and of course, as a gas turbine power generation. And the estimation that it's going to grow to triple the consumption that is needed. So what is our go-to market? We plan to go to industries, something like, which uses ammonia as their feedstock, raw material, any pharmaceutical, food industry, cosmetic. For example, I dye my hair, so for any woman that dyes her hair knows that ammonia is needed to dye the hair. And I do want all the things that I'm using to be sustainable. So for me, it is important that the ammonia would be also green ammonia. So we are looking for companies that sustainability and regulatory compliance are important for them. They are low to medium volume users. They have experience handling ammonia. Don't forget, ammonia is a poison, and we don't want regular people that are not trained to produce ammonia. And for those companies, the consistency of the ammonia supply and the price is important. We started a discussion with the companies that you see here, with BASF, with ICL, which is a fertilizer company, and L'Oreal, and more and more. So I will not go into the competition because I'm running out of time. So we are based in Israel, and we won the Cleantech 2 weeks out of 50 best companies to watch. And I couldn't do all of this without my amazing team back there in Israel. So as you can see them here, 6 of them PhD, either in chemistry or mechanical engineering. And we have Professor Ronnie Newman, our scientific advisor, to support us. So thank you. I join you.
Thank you, NitroFix. Judges, who wants to start us off?
Maybe you could tell us a little bit about your differentiation from other green ammonia approaches?
Sure. So I skipped this slide because we had no time. So something for. We are the only. So the other competitors usually are using two-step process, which uses the first step are using hydrogen. So they produce green hydrogen, and then the next step they take this hydrogen and react it with nitrogen to produce ammonia. We have a one-step process. We go directly from water with, of course, nitrogen or air to ammonia. So by having only one-step process, we can save capex, but also we can save a lot of electricity, because just the production of hydrogen requires 1.8 volt of the reaction, and our reaction is around 2 volts. So we need the same energy of just the hydrogen, but then they have a second step of the Haber-Bosch, the hydrogen and nitrogen, which requires additional energy and additional capex. So therefore, we are much more competitive, and our price should be much lower.
How much cheaper can you get to?
So according to our calculation, once we reach the performance that we are aiming to be around $350 per ton of ammonia, green ammonia.
Other questions?
Excellent. How experienced are your customers with actually running plants decentralized?
So that's the reason we would like to go with chemical manufacturers that are experienced with manufacturing. So the reason that we don't think it's right, because ammonia is being used as a fertilizer, so we could go theoretically to the farmers themselves and tell them, take this system and produce your own ammonia. But for now, we think it's not a great idea at this stage, because ammonia is hazardous material. So we would like to go to a chemical manufacturer that anyway knows how to manufacture. They know how to handle hazardous material. So therefore, they know how to produce. It would be quite easy for them to adopt additional production method.
And is there a minimum scale for these customers for you to become interesting?
So this is one of the things that we are testing now. So we've signed 2 LOIs with universities here in California. That by the end of next year, they will test like 1 ton of production of ammonia. So this would be our first system that goes into the market, and we want to test it together with our customers to see the production and to see if they have any questions. And then we can, since it's an electrolyzer, so I didn't say it, so it's a modular system. So you can start with a stack in one size and then enlarge, or you can stack few stacks together. So once we have the technology working, then it's a modular system.
I'm curious, how volatile has the ammonia market prices been overall? And the reason why I ask is, I imagine your direct customers would want to, they'd be impacted by this. This will still be a CapEx, maybe lower, but still CapEx. So I'm curious how volatile that has been and how that could impact their investment decisions, into an early stage opportunity like this.
So that's a great question, because the answer is very volatile. So for certain times, when the gas prices went up, the ammonia price went up to $1,500 per 1 ton of ammonia, even more than this. And this is what we call X factor. So this is without the additional of transportation. So when the gas prices goes down, the ammonia price goes down. So this is a lot of fluctuation within the price. So in our case, 70% of the production cost is coming from electricity. So we are aiming to have renewable electricity on site. So to whatever the demands of electricity that is needed, this is what we are going to use. So it should be quite constant price.
And maybe can you expand further on what some of the early customer learnings have been?
Sorry?
Can you expand further on what some of the early customer learnings have been?
Okay, so we had a discussion, first of all, EnBW, so this is a German company, so they are doing electricity, so they came to visit us in Israel, in our office. So what is the interesting thing? They are doing renewable energy, and in some hours, they have too much renewable energy, so they don't know what to do with this renewable energy. So one of the ideas is that once they could produce ammonia, store it, and then use it back as an energy source. So for them, the electricity price is almost neglectable because they are the one that is producing the energy. Other companies that we are discussing with are chemical manufacturers. For example, we spoke with Adama. It's a pesticides company based in Israel. So for the pesticides manufacturing, they do need ammonia. So they need a constant supply of ammonia. And sometimes in Israel, it's a bit challenge. So for some time, they've paid $2,000 per 1 ton of ammonia. And in other times, they had no ammonia at all. Just for your question, we had discussion with BASF. So BASF they have their own facility to produce ammonia, but they're using fossil gas. But since the war from Russia and Ukraine, so the fossil gas pipe was damaged. So they had no fossil gas to produce their own needs of ammonia. So they are looking for alternative production methods that are not based on fossil gas. And this is huge point.
All right, unfortunately, we are out of time. So give it up one more time for NitroFix.
Well done.
All right, so it is time for our second startup battlefield company. That company is Forest Guard. Presenting for Forest Guard is co-founder and CTO Batuan Esirger.
I'm Batuan Esirger, and I am the co-founder of Forest Guard. We detect open-air fires in the first 15 minutes. We cover over 2 million square feet, and we yearly detected more than a dozen, both industrial and forest fires. And we are just getting started.
Hi everyone, I'm Batuan.
I'm sorry for the dystopic entrance, but wildfires are emerging in an increasing rate. And if we're not careful, this will be the reality of our children. We are here to change that. I was very lucky enough to have grown up in a well-forested area, and this place does not exist anymore. In 2021, we had enormous wildfires in Turkey. I was a volunteer drone pilot, and this is the last photo I take from that place. And this is not limited to Turkey as well. This is a global problem. And do you know how much of an area burnt down in California just last year? It was around 250,000 football fields. Let me visualize that for you. If we center the Apple Park, this is what we are looking at. Imagine all this area burnt down and nothing left. Why? The problem with the wildfires is we get notified too late. Global average is around 90 minutes. And the methods that we are using right now, like drones, cameras, satellites, are slow to detect as well as expensive, and they do need special infrastructure. And it cost us a lot more than we can imagine. Just last year, it was around $500 billion for the US. This is where we come in. We detect the fires in the first 15 minutes with a fraction of the cost and without any infrastructure. Our devices analyze the air. We measure temperature, humidity, as well as gas resistance. With gas resistance, we take the fingerprint of the air, so we can say what is the source of that smoke. Is it somebody smoking a cigarette, or is it a wildfire? And also, we do provide 10 different variable measurements as well. These data are then sent through the satellite to our servers and analyzed, and if needed, authorities are alerted immediately. we provide fire detection in 3 sections. Before fire, we provide risk maps, so you know where to look for if there should be a fire. In case of a fire, we alert you in the first 15 minutes, and if somehow fire spreads and we cannot intervene in the moment, we can always predict where will it go next. Let's cut to the demo. So, as you can guess, I was not allowed to set the stage on fire, so we are connected to my co-founder in France. Dr. Ernek, we are live and here seeing you. Please go ahead. So, Dr. Ernek will now provide us with a controlled fire, and we do have a device located around 50 meters away from our fire source, and we'll see how much time it takes us to detect it. Okay, we have a good fire right now. I'm narrating over it. Because of the time difference, you can see he is operating in the dark, so time zones. But we have some lighting setup, so. If you can look closely, you can see the orange strap in the tree. Normally, we put 1 device per 3 acres, and this provides us less than 15 minutes of detection time. My and Dr. Ernek's phones are connected, and I just received the SMS notification. Thank you, Dr. Ernek. If we can zoom into my phone, I can show you the exact message that I just received. So, as you can see, this is the message that I just received, and we can click on the link and see the exact location of the fire, just within seconds. It's somewhere over the knees. Let's get back to the slides. So, we do have an online database that you can always look onto it 24/7, get the live data from the devices. And you can go up to 30 days to 60 days to see the relevance as well as the sensor readings. Our customers are private forestry and governments. We work with energy distribution companies, resort hotels, insurance companies, as well as high-risk factories. We had more than a dozen of awards, including our patent, and we have a lot of success stories as well. We have been able to interfere 14 different fires so far, one of which was an industrial fire. In this paper recycling facility, we were able to detect the fire 4 hours before the visible smoke, which saved the facility 1,500 tons of paper and $6 million in damage. And it was just a $6K installment. You can either buy our devices or lease them as a turnkey solution. This allows ease of scale for both for us as well as our customers. We have over 2 million square meters of installment in Turkey, and we are ongoing POCs in North America. Sorry, we are ongoing POCs in Europe as well as Australia and UK, and we are hoping to get to North America in the next quarter. We are a team of 7 with 2 co-founders, and we are hoping to expand our team as well as our operations. For this, we are seeking for $1.5 million in seed round investments. We are hoping to get 10,000 active devices in the next year and cover 12 times the size of San Francisco. Do you remember this map from the beginning? This damage could have been drastically reduced with just 8,000 Forest Guard devices, about $4 million. Wildfires can be reduced and controlled. For this, we need early detection, and for early detection, we need Forest Guard. Thank you.
Can you hear me? Okay, great. Judges, do you have any questions?
Maybe just some basics to start off. Just walk us through like the unit cost or understanding essentially how long this lasts, like the depreciation of this device over time, and how often you'd have to replace it.
Yeah, we do have a 5-year of field life that we provide our customers, and we have ongoing 3 years of devices right now that still function. our devices have solar panels, so you don't have to change batteries or anything. And with the satellite connection, you always have connection over the Europe as well as Northern America. And base unit cost, you can buy one device per $500, or you can lease it yearly for $250, device and the services included. If you buy the devices, first year services are included, but the next year you have to pay $100 per device.
Okay.
Could you tell us about the tech behind it? So are you using off-the-shelf sensors? Is there anything defensible in the sensor system or in the modeling that you're doing?
Our secret sauce is the model. We are using off-the-shelf sensors, but we are producing our own custom motherboards, and we tend to keep everything modular. So in case something breaks down in the device itself, we can always take them back, change those parts, and send them back in.
And a follow-up, because you already have these out on trees, are there other applications outside of wildfires where this extends to and makes sense?
Yes, we pivoted to detecting fires in the industrial facilities as well, the example that I showed. The thing is, we do abnormality detection in the air, so we can always say the devices learn about the area normals, and if something goes out of the ordinary, we can always get notification. So this can be implemented for toxic gases, harmful gases, and flammable gases as well.
So if we were to talk in, let's say, 3 to 5 years and everything's going successfully, what would your guess as the split between government and commercial use cases be?
Probably around 70 to 30. 30 government, 70 industry, and maybe consumers.
If I had to just follow up on this and push you and decide, why not the inverse? To me, the immediate reaction of what you're getting from the ROI to a customer in a much localized environment where you can probably control reliability seems really interesting. Why not lean in further into the commercial use case and the factory use case rather than the government?
We are actually leaning in more into the factory and the commercial use case. So they are a lot faster than to act regarding the government. Yeah, right. So we are going there where it hurts the most. So it's 70% industrial and consumers, and 30 government.
Got it.
Speaking of a high-risk live demo, I've never seen a live fire during a demo. How do you think about maintenance, and what's the economics on actually maintaining, like on a per acre or hectare basis?
Normally we put, for high-risk areas, we put one device per 3 acres. And for maintaining, we do not require anything out of the ordinary. We had some cases depending on the forest types. Sometimes the solar panels need some cleaning, but we can always measure those battery levels and solar charging levels through our system and alert our customers accordingly. Right now, we have devices about 2 years running without any maintenance needed.
Maybe you could walk us through how big do you think this market is, and given your customer mix, where do you think you can take this?
Our most easy to adapt customers are, again, industrial ones, especially with the high flammable stock ones. And when we're talking about Middle East and Europe, we do we do have a market around $18 billion on fire detection in industrial facilities. And right now we are opening a branch in France to reach out to European customers at the moment, as well as I'm running the Mediterranean and Turkey operations from Istanbul. My co-founder, as you can guess, relocated to France and having some new business relations over there.
Any final quick questions? Okay, if not, give it up one more time for Forest Guard, the first startup battlefield company to set something on fire for their demo. Thank you so much.
Well done.
Next up, we're going to have Spiral Wave. Presenting for Spiral Wave is co-founder and COO Adam Ahmad.
Hello, my name is Adam Ahmad, and I'm the co-founder of Spiral Wave. We are the first company in history to make liquid fuel out of thin air, and we do that at price parity with fossil fuels.
everyone. My name is Adam Ahmad, and you guys heard that right. We're making fuel straight out of air, and we're the first ones in history to make fuel out of air. And the nice thing about this fuel is that it's convenient. It's liquid fuel, just like your gasoline, like your diesel. So it's compatible with existing infrastructure. But for us to get to this point, we had to make this huge paradigm shift in how we approach the technology in making renewable fuels. So currently, there's this industry called the carbon capture and utilization industry. And this industry basically recycles CO2 and converts it into valuable chemicals and fuels. But the issue with this industry is they're using technologies that were established hundreds of years ago. And they use technologies like membranes, catalysts, and zeolites. You guys probably don't know those terms because those terms are not commercial today. You don't see them in the industry today. So what you're looking at here today, if you can go to the next slide. Yeah, so this is the current supply chain of making sustainable fuels. You have to capture the carbon dioxide, you have to get the H2 from electrolysis, and then you put them in these reactors, and you combine the H2 and the carbon and produce renewable fuels, whether it's gasoline, whether it's diesel and jet fuel. But the issue is, you're doing the capture and you're doing the electrolysis. Those all cost steps. Every step you reduce the efficiency. So what we've done is we've removed the capture and we've removed the electrolysis and we went straight into the fuel production. So what we have here is basically a reactor that reacts with carbon dioxide straight from the air and water and makes renewable fuel. So if you can go to the next slide. So this is our reactor. We're sending these pulses. It's made out of chips only, steel and chips. So this is like the first microchip-based, fuel synthesis reactor. It's like Silicon Valley before the chip revolution. They were, they were stuck with these computers that would fit the size of this room. But then they moved to the chip, and that's where the revolution happened. So we've done exactly that, and we put the chip, the whole climate chemistry inside this chip, and we're sparking this new era. So the fuel that we produce is methanol. So if you can go to the next slide, please. And to best describe what methanol's potential is, by referencing this Nobel Prize winner, George Olah. He's a legend in the fossil fuel industry, and he says, if we can produce methanol efficiently and on a large scale from atmospheric carbon dioxide and hydrogen, it could replace oil and gas both as a fuel and as a chemical raw material. So we're talking about oil and gas, the two largest markets, and if you can produce them efficiently and on a large scale, it can replace both of them. And just to go a little deeper into that, can you go to the next slide? Yeah, so methanol is used as a fuel for the maritime industry, and it can be converted into all the other chemicals and fuels. And it's also a convenient energy storage because it's liquid at room temperature. So, it's compatible with existing infrastructure. So, as you said, the issue with this vision is making it at a large scale and efficiently. And, our technology promises that and achieves that. And I wish George Olah was still alive today because his vision is coming to reality. And I'm going to show you, here it is. Can we go to the demo? Let's turn to the demo. So this is my partner, he's Abid. He's currently in our lab in Austria. He's heading to the reactor. And
hi. So this is our reactor here. I hope you can hear me. So this is basically a 2-meter chamber in the air, and it's the world's first cold plasma reactor that can convert CO2 into methanol. And here we got a methanol sensor that we can monitor converting CO2 from air into methanol. So let me turn on this thing here. So it will take a few seconds to stabilize the plasma. And here we go. So these are, for every pulse of this plasma, we convert CO2 directly from air into methanol. So if we look to the temperature for this plasma, it's almost room temperature, like 100 Fahrenheit. And if we go to methanol sensor here, we can see it starts to read out and increasing the value of methanol slow as we, like the bubble keeps going up. So this is really the world's first reactor that converts CO2 directly from air into methanol in one single step. So thank you.
Yeah, so we're not capturing the carbon dioxide here. This is straight air and water. And we miss the water into the chamber, so we get the hydrogen, and we react in both, and we capture the methanol in a water tank. So what this does is it brings the cost of capture and carbon capture and utilization to zero, because you can capture the methanol in a simple water tank. Because methanol dissolves in water, so you don't need to have these membranes and other sorbent materials that separate the carbon from the air. So by converting it first to methanol and capturing the methanol, you bring the cost of capture to zero. If you can go to the next slide, our plan is to put this reactor in this container where we ship it to our clients. They have industrial emissions, and we convert their industrial emissions into methanol directly. So we take their emissions and we convert it directly into methanol. We also have plans to distribute it in the future, this container, and you can produce methanol anywhere that has air and water, so basically everywhere. And so if you can go to the next slide. So as we said, this is a chip-based.
Wrap it up.
Yeah, this is a chip-based reactor. This is how we plan to scale this up. We go from a small reactor to a larger one, and we plan to distribute these throughout the world. And you can remove gigatons of CO2 with solid fuel reactors. It's 100 times more efficient than any other reactor. So that's our technology. If you go to the next slide. Yeah, so right now we completed the plan.
Pretty much out of time. Can you give us a final thought?
Yeah, so last but not least, ultimately, we're the first company to make fuel out of air. I mean, that's super revolutionary. This is a new paradigm that we're entering in. It's like you can just simply plug it into a wall outlet and put it anywhere in the world, and you're making liquid fuel. And this liquid fuel is compatible with the existing infrastructure. And you recycle gigatons of CO2 into fuel. Thank you.
Thank you, Spiral Wave. Judges, who has questions?
Very cool, thank you. How would you characterize the key technical risks as you scale up?
Can you repeat that question?
How would you characterize the key technical risks as you scale up?
So technical risk-wise, there's no technical risk. The reactor is producing methanol. You guys observed it. The only steps to continue further developing this is increasing the airflow so we can get more CO2 interacting with the plasma. And that's just optimization processes. But technical risk, there's not, with what's currently established, there's no risk. That's for our microbeam. That's the one that does from air. But but the reactor that converts industrial emissions into methanol, that one is completely commercially ready. So we take flue gas, and you don't have to worry about having a low concentration of CO2, because air is 0.04% CO2. With industrial emissions, it's from 6 to 9, 10%. So you have more CO2 that you can convert into fuel.
So for that device that you showed, that you said is commercial ready, what would be the cost of methanol coming out of there?
Right. So obviously, this reactor's main cost is electricity. So that's what's the input. So if you have 2 cents electricity, you can produce it below its price point in the market today, which gives you the chance to sell it at price parity.
And then for scaling up, you said more airflow was one of the key levers.
That's right. I need to interact more CO2, get more CO2 crossing the chamber, so you can convert more of that CO2 into methanol.
So if you solve that problem, you could then be cost competitive with fuels.
For the microbeam, for the one that does it with direct air, and we plan to do that next year. But for this year, we're working on commercializing the flue gas to fuel, because you don't have to worry about the low concentration of CO2.
How are you? So I think I understood the response to Rohan's question. I mean, maybe there's no science risk. I mean, there's always engineering risk, I think, in terms of scaling. But I'm curious your take on what is your IP strategy here as well? Assuming everything is looking like it is, what are the core IP components that you have to protect?
I mean, it's the ignition. That's the core revolution here. It's how you ignite low temperature plasma at room temperature. I mean, at atmospheric pressure. So this is the core technological breakthrough, the core scientific breakthrough. It's, plasmas, they're hard to ignite, and they require super high energy to ignite. And when you ignite them, they're ignited in a non-uniform way, so the energy is distributed non-uniformly. So you have like cold spots, hot spots, but the core here is creating this uniform plasma. So you have even temperature throughout the plasma field, and you're creating this avalanche of ions. It like goes from the bottom to the top, and that's like just a much more efficient way. So you have an efficient way of igniting this plasma that's low temperature, which enables the production of methanol. So there's different parts that go into the IP, but this is the core breakthrough in the science. That's like the core breakthrough in the microchip, and how you create a microchip that enables this plasma to ignite. But then we add the software over that on how to produce the methanol, how we calibrate different parameters of the chamber of the reactor to bias towards the formation of methanol.
Maybe walk us through, what does commercialization look like, and like if you were to predict the next 2 years of the company from a scaling perspective, what do you want it to look like?
So right now, the largest methanol plant produces 2,500 tons of methanol, and to put that in perspective, that's 1/10 of what a single container vessel ship consumes. So it's super not scalable at all. With 10 containers, we can have today the largest methanol plant. And our plan is to sell these containers to industrial emitters, and they can convert the methanol, they can convert the CO2 into methanol, and we can sell it to these shipping companies that are urgently needing green methanol. And we can also have our private plants where we can create fuel directly from air, independent of anyone, independent of a flue gas emitter, just wherever we have the cheapest cost of electricity.
All right, give it up for Spiral Wave.
Thank you, guys.
Okay, our next presenting company is Level Zero Health. Presenting for Level Zero Health is co-founder and CEO Ula Rustamova.
My name is Ula, and I'm the CEO and co-founder of Level Zero Health. We're pioneering continuous hormone monitoring, using first-of-their-kind DNA-based sensors that allow you to track your hormones wherever you are.
Cool. Hi, everyone. Hormones. They regulate almost everything in your body, from even before you were born to how you feel right now and throughout your all major life events, puberty, aging, reproduction, and so much more. That data is critical, yet today, if you wanted to measure them, you have to physically go to a lab for someone to take a blood draw. That's not only invasive, it's disruptive, and only a single data point. Until now. Now I can wear this, a DNA-based sensor that allows me to track my hormones wherever I am. Now is the time to build this company and launch this product. Awareness in the population is rising rapidly. Continuous glucose monitors have normalized devices like ours, and most importantly, this technology has only been possible for the last 18 months. Due to expiration of foundational patents and a breakthrough in research last year. And we're leading the race with our own breakthrough. Just about 3 weeks ago, we showed that our sensor measures all of our analytes across 98% of human clinical range. That's one of the biggest challenges in sensors, going into such low concentrations in the human body. We have more great news. Our goal is to launch our continuous hormone monitoring device. It monitors your hormones for up to 2 weeks at a high frequency. But we'll also have figured out an accelerated path to market with our patent-pending intermittent monitoring device. It has a shorter R&D timeline, lower regulatory burden, and allows us to bring immediate value and build presence in the market, but also building our data and learning to grow us further. Let's have a look at our device. Can we have a camera? Cool. So this is our intermittent device. It allows you to take multiple measurements throughout the day. This particular one has 3 measurements with 2 analytes each. It's a tiny microneedle. It's 0.5 millimeter long. So when the user wants to take a measurement, they press a button that inserts the needle and extracts interstitial fluid out for external analysis. We're not going to show what's happening behind the scenes. It's all nanoscale, so we can't actually show in nano. So if we can switch to video, please. Cool. So when you insert the needle, it extracts the interstitial fluid, and the paper inside is coated with single-strand DNA. These short DNA sequences are almost programmed to bind to each of the analytes, and when they bind, they produce a color change. So the user can take out the paper strip and put it into a camera box where they can take the precise measurement, send it to the user app, as well as the clinician portal, where they can see this data real time. Just to give you a bit of a perspective, continuous glucose monitors truly revolutionize diabetes care. The company that makes CGMs makes $4 billion a year, and that's just from glucose. We're addressing markets much bigger than that. Starting with IVF and low testosterone, where clinics and patients know the pain. For IVF, you literally have to go to the clinic to take a blood draw every 2 days for weeks. For low testosterone, for diagnosis, as well as throughout treatment, you need to take a blood draw. We're completely replacing those blood draws, allowing clinicians to take more measurements remotely, non-invasively, and show real-time data. In the last 3 months alone, we've secured 3 million in LOIs from some of the leading clinics, and they will convert to 8 million ARR at full adoption on the 2nd year. These clinics are also our design partners, and most importantly, we're validating our device on-site in humans in 6 to 9 months already. This is just the beginning. This is a kind of a breakthrough that we need for all sorts of markets. Individualized contraception dosage, personalized medicine, lifestyle, and so much more. Markets totaling $250 billion. Our initial market opportunity is already massive, with more than $500 million ARR potential in the US alone, just from hardware. We've only been around for 10 months, and our small team has been able to move so fast because of how incredible our team members are. We have more than 20 years of experience in DNA-based sensing and nanotechnology. My name is Ula. I'm the CEO and co-founder, and I had a wearables device company at 16 and led multiple enterprises at Palantir. My co-founder Irene and CTO developed medical devices at Philips and launched electrochemical sensors before. Our team has now expanded with some of the biggest names in fertility, from Harvard, CCRM, Mount Sinai, and HIMSS, and we're very happy to have them. And right now, we're bringing more people, investors and partners, and we're just signed our lead for a $6 million raise that we're going to finalize in the next 2 weeks with a little bit of room for strategic investors as well. If there's one thing I would like you to take away, it's this. We're at a precipice of a real change these markets need. A world where your hormone data is as readily available as your heart rate or step count. We're not only here leading the race, we're set to win this market. Thank you.
Thank you, Level Zero Health. Judges.
Maybe I'll start it off as a physician by training. First of all, this is really, I think, needed in terms of, this is an issue that a lot of conditions can be helped by. I think the devil's a little bit in the details, so I'm curious to ask, first of all, baby steps, what do you need to achieve technically to have parity of evidence? I saw you have some FDA clearance ideas, so walk through what you need to do before you get to mass market. I'm sure you can do some D2C, but first.
Of course. I'll cover some, and then I'll see if Irene wants to add anything. So The most important thing that this technology can do that other devices like urine tests, temperature tests, et cetera, cannot do is correlate directly to blood. The tight correlation that CGMs have, because this goes through interstitial fluid. We're building the same data set. So in 6 to 9 months, we're showing that our data across all human ranges in both simulated interstitial fluid and across the populations matches directly to blood measurements. So you can trust it as much as you can trust a blood draw. So that's one on the clinical level, to be able to build trust, credibility in research and go to clinical use cases. That's the number one thing. There are a couple of technical things that we need to do to get to that space, so I'll let Irene answer that one.
Yeah, additionally, we're right now working on modifying our single-strand DNAs to capture these analytes in a very, very specific way. So we have already achieved detection in very low 10 nanomolar concentration ranges with these aptamers. The next is we're going to move into real interstitial fluid to first build a data set on the relative abundance of these analytes and then correlating to our sensors. So all of those work is planned to do in the next 6 to 9 months.
Great, thank you.
We're probably, like, one of the biggest challenges is going into the ultra low concentrations, which we've already kind of solved and shown consistent results. So it's about stabilizing that, going 1 order degree smaller, which is not a big issue given that we went from like 10 micromolar to 10 nanomolar range, stabilizing that and running a validation study in the next 9 months or so.
And talk a little bit about the regulatory pathway and what precedents you're going to use.
Absolutely. So for the continuous device, we're setting a de novo. That is a strategic move. There are a lot of other products that claim to do continuous monitoring, and we want to set exactly what that means. High frequency correlated to blood, so that's de novo for sure. The earlier product is a 510K, particularly for progesterone and estrogen monitoring for IVF. Today, those like both urine, saliva, and urine tests are exempt from regulatory altogether. You just notify FDA. But because we're doing interstitial fluid, we're tripping that up to a 510K. So only 90 days to review smaller scale studies that we're going to be doing with our actual clinical partners as well on site here in the US, as well as in Europe in CE, kind of in parallel. In Europe, which is actually like double the size of the US, but they have higher price sensitivity, the regulatory pathway doesn't have a distinction between a 510K and de novo, but today the auditing takes a little bit more time. So the way we think about it is a 510K, lowest barrier, like fastest, most likely. CE, we're going to launch at the same time, but it will converge a few months later after the 510K, and the de novo is the most expensive and obviously the lengthiest one that we will do in 2-3 years for the continuous one.
And how high is the spend in these initial applications, and
Absolutely.
where do you see that going?
Yeah, so the initial device is a single-time use patch and a camera box. The patch itself is $60 to $90, and the patch is $200. So for a single IVF cycle, that's $440 per cycle. For a medium-sized clinic, we're talking about around 500K ARR, given that they do 1,000 cycles a year. And a typical cycle price is about 15 to 20,000, so it's like a drop in the bucket. It is, in most cases, on par with current price that they spend on operating the lab, but we're also reducing the costs for the clinics. We're getting rid of 80% of their blood draws, full-time employees, what they call satellite labs, where they have in other regions, rural areas, where clinicians travel maybe once a week to see their patients. So it allows us to bring sort of benefit both to patients as well as the clinics themselves.
And how do you think about distribution? Is this something that you'd want the end users to opt into themselves, or something that you would think the partnerships with the various clinics would help you distribute? Yeah, how do you think about that?
Yeah, this is all direct B2B, large-scale sales. So with all of the clinics, they're buying it in bulk. In some cases, they want to put it like at the beginning. Even the way our LOIs and our growth is scheduled with them is about 10 to 15% adoption rate at the beginning, launching to 25 and 75 over time. 75 is what they think is going to be the default. In some cases, we think the clinics will probably put a margin on it as well. It's obviously up to them. For example, egg freezing is a very interesting use case where you typically, as a single woman that doesn't want to deal with fertility at the moment, career-driven, doesn't want to come to a clinic every 2 days. So we can see, like we've heard our partners say that they might actually add an additional price on top to just do it, not like remotely completely replace the blood draws. So I would say that distribution is completely through clinics. Over time, we will move to B2C for other use cases like perimenopause and such that are not so centralized as an IVF clinic is, but that's a later time. Yeah.
And how would the readout work for continuous monitoring versus intermittent?
There is no readout for the continuous one.
So the signal capture is a little bit similar to how the continuous glucose monitors work. You have a sensor that's directly embedded into the interstitial fluid, and it detects the change in concentration proportional to the change in current that's detected. So we're basically directly measuring current, and we can use a low-power Bluetooth that syncs to the phone and then process it in the cloud and send it back the results, essentially.
So it's fully integrated.
Yeah.
All right, give it up for Level 0 Health. We have one final battlefield company presenting in this session. That company is Solidion. Presenting for Solidion is co-founder and CEO Alushan Taiwo.
Hi, my name is Alushan Taiwo, founder and CEO of Solidion. We're building autonomous deployable factories, have built entire aerospace products like aircraft and rockets, the speed of software.
Hey everyone, can you guys hear me? All right, excellent. Well, thank you TechCrunch for having us here. We're super stoked about this. My name is Alushan Taiwo. I'm the founder and CEO of Solidion. We are building tomorrow's factories today. If we look at my background here, I've had the immense pleasure at working some of the world's leading aerospace and defense companies, and I've devoted my entire career to figuring out how we can go from ideas to actual concepts that fly and make money. And what I found out is American manufacturing is actually in a really difficult and rough spot right now. These news articles, they're trying to tell you guys something. Manufacturing and reindustrializing America is difficult. And right now, we've just been spending a ton of time trying to figure out how we can actually restart factories that have been dead for tons of years here. What we found at Solidion while we were creating this company is that 50% of our workforce is eligible for retirement over the next year. And we're trying to make advanced, amazing technology with tech that has been around since the Wright brothers. This doesn't scale, and we need to change as soon as possible. At Solidion, we're doing this, and we're changing this venture scale by taking off-the-shelf robots and pairing it with our software we call Allopium. Current manufacturing in the US, we do have automation technology that tries to help us redo and reindustrialize here, but you have to make dozens of these robots that do one singular thing, and that's a problem when you talk about trying to scale. On top of that, you have to have dozens to hundreds of engineers that actually go and reprogram these systems. Very, very expensive, especially when these people are actually leaving these factories. For our customers, they need all these robots to do things like metal fabrication, post-processing, assembly, and quality management. Once again, lots of expensive assets to go and do 4 things that actually could be done on one platform. We inject Allopium into these robotics to enable our customers to do this. At Solidion, we now, with our Allopium tech, we actually now let one robot do all 4 of these jobs here for less than the cost of a full-time engineer's salary. Big leaps forward. This is how our robots see the world, effectively taking in dozens of data points every second and making adjustments on the fly to make them autonomous. Big deals when we talk through data annihilation and also ways to collect and make innovations from that. So we now go from factories that are very crowded, that look like this, to factories that are much more simpler, much more enabled. An example of this is a propulsion tank that we printed for a rocket company here that went fully autonomous. We had no one in the loop really to go and build this product, and you can kind of see it off stage here in all her glory. We're super proud about this. Many reasons for that: this product stands about 6 feet tall, weighs a little over 75 pounds. Traditional manufacturing says it takes $100,000 to do this with fixed tooling and assets, and 4 to 6 months to build this product. We did it for $10,000 and in 6 days. That's what we're excited about here at Solidion. But please do not take my word for it, because these are big numbers. This is Silicon Valley. How about we go to a live stream here for our demo into our factory? We're actually based here in Berkeley, California. We got robots building a second version of this, which I'm super excited for. This one will actually get burst tested and actually go through some testing for a customer. What's really exciting about this process is the fact that we can build things that are about 10 feet in diameter by 10 feet tall. So pretty much your minivan and a little bit more than that. We're also really excited the fact that you can see, how many people do you guys see in the shot here? There's literally no one here except the guy taking our video, and we're super excited about that. And so as we finish up some of the metal fabrication here, we actually have that robot on the slide there that's able to go and do more scanning and get those data points that we like. Now, we're focused on taking this innovation in 3 distinct areas: in the aerospace, defense, and maritime industry. These are places that have generational lead times items for parts, and we need those innovations to change and do it today. And so at Solidian, we are targeting the autonomous aerospace and defense markets. What's exciting about that is we have $500K in projected revenue for the end of the year this year, which is super exciting. A 2-year-old startup should not have this traction, but that just tells you the state of American manufacturing. And as we scale from R&D contracts into actual production, we are looking at $5 million in projected revenue next year across those same customers plus a little more. Once again, big leaps forward from a small company. Our vision is to take manufacturing on this planet and be able to take the things that we've learned and take it to space eventually. This is how we actually get to being a multi-tiered, multi-planetary species. Rockets are cool. We need manufacturing to take us there. If you look at our team, this is the real proof point of our company beyond just the technology. These are the people that actually make the company work. We're dreamers, we're innovators, we're builders, we're engineers. And what's super exciting about that is while we're VC-backed, we're blue-collar. And that's what's the most exciting thing. We're not just tech bros that are building a product. We're people who have done this before in other industries, and we're building to build it again. Now, previously, we've raised $6 million from world-class investors that exist here in Silicon Valley. What I'm most excited to do today is to pronounce we're raising a $20 million seed round. Once again, big numbers from a small company, and I'm super excited that we have some of the best already backing us. At Solidian, we're not just keeping up with the future, we're redefining it and we're forging the path forward. So, join us in launching America into the next industrial revolution. I'm Olu, thank you for your time.
Thank you, Solidian. Very nice looking jackets, by the way.
Oh, thank you.
Judges.
Could you tell us about your customers and how do you integrate into their workflow?
Yeah, definitely. So we use our factory in Berkeley to be able to take initial products onto our robotics, show that we can actually qualify that system before they make any kind of capital purchase expenditure. And then once we show that it's a qualified process for building hardware, we copy and paste our software onto their existing robotics. And that's a big deal versus having to go buy a machine from us or us try to pitch guys like you and say that we're going to scale by buying $100,000 or 100,000 square feet of real estate. That doesn't scale very well. And so we think there's a hybrid approach, and that's how we were working with our customers. Our customers, specifically, they're in the defense and aerospace, so they are big primes. One of them, I don't know if you saw on the screen, is actually is one of the bigger primes, and so we're actually working with their innovation teams. They're one of our big values for revenue for this year. So we're working with folks who are using us to start hitting into production, and then they go to our customers and their suppliers who upload our software onto their robotics. So it's a tiered play of build the demand up top, and then use the bottom people that have already been building their supply chain up from our software. So hopefully that makes more sense, but happy to dive in deeper.
So their suppliers don't have to invest in new equipment. They're taking your software and layering that on top of what they already have. Okay.
Yep.
What level of complexity can you handle today, and kind of how do you view that kind of progressing?
Yeah, definitely. Yeah, a very good question. Right now, we can build things bigger than your minivan, and so maybe even twice as big as that tank. And we have basic assembly capabilities. Where we will be in about a year is going from raw material to final product through the factory. We're sprinting towards that, and between that, there's some milestones that we have with our investors to be able to show that on smaller products, things like autonomous submarines and such like that. But you'll see some more news from us on that.
And just a quick clarity question. In terms of that cost reduction, is that primarily labor-based, or is it also like materials or time? Time, I guess.
Both, and I'm glad that you know that. But basically, labor, we can actually have one engineer run 3 of these cells that we've just saw on our live stream demo. So that's the first bit of that. The second bit of that is our raw materials, our input is actually welding wire, which is a very understood industry, right, that's existed for hundreds of years. And now you're able to take that into what we're doing for the metal fabrication. That's a huge cost reduction for us. So it's a combination of using simple materials that are available on the market anywhere in the world that people already use, and reducing the number of people that actually have to go and program robots to almost none at this point. We want a 14-year-old boy to basically be able to walk into a factory and build giant metal Lego blocks.
Except not actually have a child work in a factory.
Let us be clear, we're not hiring 14-year-olds. So.
And what was the key technical unlock to make your software work across different robotic platforms and different arms?
Probably not the most Silicon Valley answer, but we were really unsatisfied when we started the company to find solutions that actually program industrial robotic arms. So we just did the work. So it was a combination of raising money. The first year of the business was painfully trying to figure out how to get that to work. Companies such as Relativity and others, they've gone through this path as well. They took other areas into it, but we really put a defined moment on, we're in the Bay Area, we're by some of the best software talent in the world, we need to use that to build this company. And that's what we did.
And maybe walk us through, you kind of touched on this a bit, walk us through the product roadmap over the coming years, particularly as it maps to the different verticals that you want to address.
Yeah, definitely. So we do a lot of materials development that enables us to unlock the 3 verticals that we talked about. The way that we're going from it is, first of all, can we metal fabricate things? We've shown that proof of concept here. Assembly is the next biggest piece because that allows us to integrate into our customers' hardware. And so what I'm hoping for is if I ever get a chance to come back to TechCrunch, next time it's a fully integrated rocket that you guys would be able to see. But things like that, that's where the roadmap gets in towards. And so the company takes a dual path at that point, one in which we focus and hunker down on building the best software product that we possibly can. And the second piece of that is then taking what we know and actually start to apply it to products that are fully designed and built for this system and being able to work with our customers to commercialize that. It's a very lucrative way to scale the business over time.
So to do that, you would then have your customers designing specifically for your production processes. So what is that? What do you need? What do you need to build for them then?
I'm glad you asked, and that's what's super exciting about what we're doing. Those data points that you saw on how we talked about the robots see the world, that's the data points that you need to be able to feed back into an AI to be able to tell you how to effectively design products. So we're already collecting this data. That's the whole point and why a software integration play is the smartest path for us as a manufacturing business.
So you'll give them a new design software, or you'll plug into what they already have?
Yeah, we'll plug it. Well, it's a matter of both, right? It's taking those data points and being able to plug it into a design software that we build as suggestions. But our customers can also take those design points as well too. The data that they really care about is how do we get this to be a repeatable process. What we care about is how do we get this to be a repeatable process for new products and emerging tech lines, so we can de-risk manufacturing.
Do you benefit from, or are you indifferent to, improvements in the foundation model, robotics foundation models?
Well, do you actually mind expanding on that piece?
Yeah, so there's a number of teams I think right now that are building the foundational model for robotics, physical intelligence. There's a number of one of these that are in the news, and I'm wondering, is that model improvement something that you can benefit off of and build on top of, or are you kind of adjacent to that in parallel to those improvements?
We built a modular, flexible system to do just that, and that's, once again, I think that's our secret sauce on traction, is we're not trying to overcomplicate it if we don't have to.
Got it.
Okay, give it up for Solidian.
Well done.
All right, that wraps up session 1 of the Startup Battlefield. The judges are going to follow me backstage, or they're going to help us choose some finalists. Before we do that, though, let's have one more round of applause for our Startup Battlefield judges.